Yeah, we did a different one.
We did like a
We did a random one just so that you had another example, because the two that were even were both degree problems, so I wanted you to have a radians problem to look at as well.
Can you explain that example problem again?
This one?
Yes.
Yeah, so basically with these are the quadrantial angles. So it's just the stuff that's in green. So it would like fall on one of the different X or Y axis on one of the sides. And so then we're just looking at the point 1, 0, or if it was up here, it would be 0, 1, over here, negative 1, 0, or 0, negative 1 down here. And we're just using those points to solve sine, cosine, and tangent. So we're just using the X and Y values to find them. And then R we did by still the Pythagorean theorem with the numbers that we were given.
Okay. Can you explain the one with the radian?
Yeah. Oh, so like the counting part. Yeah. So yeah. So basically, that's why when we did the unit circle, I taught y'all how to count it around so that you could see, like where everything is. So let me. It's gonna be too hard to find it on my iPad. So how like we counted around, so we'd be like, okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and we kept going. We can do the same thing with these. So I started here, and then I did, so this is 0, and then 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So I just keep counting around. And then if it was negative, I would just do the same thing, but in reverse.
So is the denominator like the increments that you count by?
Yeah.
Okay.
So the quadrantial ones are always going to be over 2, so it's always going to be the ones that hit the axis. But the other ones are just whatever the denominator is all the way around. And some of them reduce, like the pi over 6s will reduce to the pi over 3s as well. Does that help?
Yes.
Okay. All right, so then the next thing here, let's just stay on. That would be great. Okay, so the next thing we're looking at are the reference angles. So these say to sketch the angle, then find its reference angle. Okay, so for 16, we're given the angle negative 100 degrees. Okay, so we're going to sketch it.
Does sketch mean like guesstimate?
Yes. Okay, so we know that from here to here is how much? 90. So I need to go a little bit farther. Okay, so this is the angle. The reference angle, though, that I am looking for is actually the one that touches the x-axis. This is what we call theta prime. Okay, now back in your notes, you should have written down those things about the different quadrants and how to find the reference angles. Okay, so what is the one for how to find a reference angle in quadrant 3? With degrees. So it should say theta prime is equal to, and then something.
Theta minus
equal to theta
minus 180.
Okay, theta minus 180. Okay, now something to notice here is that I don't want to use the negative angle. Okay, I want to actually use this angle as my theta. Okay, I want to use the one that's actually starting here. I want to use the positive one to find this. Okay, so from here all the way around to here is what? 270, but this is 10 this direction, so how much is that? So 260. So theta is 260 degrees minus the 180 degrees. So what is theta prime? 80 degrees. So this reference angle here, theta prime, is 80 degrees. So from the axis to the angle, it's 80 degrees, is what this is telling you. All right, let's see. 18. 320 degrees.
This is cool. Are you screen recording?
Yeah.
'Cause I didn't remember. So.
Yeah. I know, I freaked out for a second. I was like, did I start it? But yeah, I did start it. I looked up and I was like, oh no. All right, so 320 degrees. So I start here. Okay. What? Oh, wrong color. 1 second. Red. Okay. Try to keep this consistent with colors. So I start here and I go around. That's 90, 180, 270. So how much farther do I need to go?
20. I mean, not 20. Wait, no.
50.
50. Okay. So just ballpark. Okay. This is.
And then the whatever it is for quadrant 4 is theta prime equals theta minus 360.
I clearly have it written backwards over here. That's exciting. Okay, so then the angle theta prime is this one that touches the x-axis. Did you say 360 minus theta or theta minus 360?
Theta minus 360.
Oh, I have
You could be wrong.
I
might have read it wrong.
I have 360 minus theta.
Okay, that's what it should be. So if I had it written as theta minus, that's why I was like confused. If I had it written as theta minus 360, that was my bad. Switch it. It should be 360 minus theta. That was, yeah. Okay. Because we want the angle to be positive, and if we subtracted 360, it would be negative. So you would just have to make it
Minus theta.
positive. Okay, so theta prime is equal to 360 minus theta.
So would the theta be the 320 because it's positive?
Yep. So if it's positive, we just use the angle that was given to us. If it's negative, we have to use the other one. So this is my theta's in red. Theta prime is in blue. So theta prime is equal to what? 40 degrees.
It's not hard. Not hard. Yet. Maybe.
It's not bad, right? All right, so then the next one, so those were in degrees, so the next ones are going to be in radians.
Actually, that shouldn't be too hard.
Typical pattern. Okay, negative 5 pi over 6. It's funny, like in every single section, the first like row of problems is in degrees, and then the second row is in radians in the book, the way that they do it. All right.
You just assume people are gonna have a harder time with
Pretty much. It's not like people are, I mean, like you're used to counting just like numbers, like degrees, but counting in radians is a little different. So this one's negative, so which direction am I going? Down. Okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, I'm going to try to round this off a little bit better now. But somewhere over here. Okay, so this is theta, but it's negative.
It's theta.
Huh? Oh, somebody said something.
Yeah, I'm just like.
This is theta, but it's negative, so I'm going to have to use the other one. But my theta prime, always in contact with the x-axis, so it's there. Okay, so the positive theta value that I'm going to use starts here and goes up and around. Okay, so this is actually the theta that I'm using. Okay, which is what?
Pi. Wait, that's wrong.
I don't remember it.
That's 7 pi over 6.
Okay, so this is 7 pi over 6.
Or, well, 7 pi plus 5 pi is 12 pi over 6.
Yeah, you can always do 2 pi minus whatever the value is, the 5 pi over 6.
Oh.
Or obviously I could change this to be, if I wanted it to be in the same thing, and then I would figure out that it's 7 pi over 6 is what's left, which is this angle, the positive one. So I have that now. So what is the formula for quadrant 3 for radians?
Theta prime equals theta minus pi.
Theta minus pi. So this is going to be 7 pi over 6 minus pi, but I want it, obviously I need a common denominator. So what would give me a common denominator if I change that to what? So 6 pi over 6.
Yeah.
So then my answer, theta prime, is equal to what?
Pi over 6.
Pi over 6. Okay, now at this point you might be looking at some of these and thinking, well, I just, in general, know what these are. I can just visually see what these are. You still have to show me your work. No work, no points. This is your warning. Oh, dear goodness. Okay, 22. Leave room for a nice large graph because it's going to be annoying. This is the last,
What's the number? Just give it to us.
this is probably the last problem that, well, actually we might do one more after this.
I can't do one.
Just give it to us.
15 pi over 4.
Oh.
You did
Of course
the
it
All right, so I'm just going to get this and do it here, and then that way I can just draw it. Actually, here. Brief pause. This is what we're going to do. We're going to count it together on my paper unit circle. Oh, no. Nope. Okay, we're just going to have to do that, and it's just going to be a little bit dark. All right, so I need to get to 15 pi over 4, so I'm going to see where that's going to fall here, and then I'll actually draw it out on the thing so you can see it. But this way we can count it. All right, so I start at 0. I'm going to start out here so that we're actually going in increments of pi over 4. Okay, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So I've gone around one full time. So 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, right? Yeah. 13 pi over 4, 14 pi over 4, 15 pi over 4. Okay, so it's going to be down here. Okay, where 7 pi over 4 is. So,
like a whole spiral on
so going around one full time, okay, is 8 pi over 4. I need to go around almost another entire time, okay, and I get to there. So that whole thing is my theta.
Okay. Because it's positive.
Yay.
Yeah. Okay. Then my theta prime is what connects with the x-axis. Okay. I'm saying that over and over again because inevitably somebody is going to connect it to the y-axis.
I thought
It
I did for a
happens.
second, but I didn't.
Now, 15 pi over 4 is bigger than 1 time all the way around. So I want to change this. What is the same angle, or what is an equivalent angle that I can use to be able to use my formulas? What did we say on the unit circle that it was?
7 pi over 4.
Okay, 7 pi over 4. So I'm actually going to use 7 pi over 4. Here, hold on. Let me change color so it's not confusing because I've been doing theta primes in. This is equivalent to 7 pi over 4. So when I'm using the formula, I want to use something that's less than, if it's something that I know, if it's a known value. If it's one of those weird ones that we don't know, then obviously it's a little different, you know. But if it's a known value like that where we know where 7 pi over 4 is, use that one instead. So, formula for
2 pi minus
that
theta.
quadrant. 2 pi minus theta. So theta prime is equal to 2 pi minus theta. So 2 pi, another way to write that in terms of pi over 4 is what?
Pi over 2. No.
I need it to be, because I'm going to be subtracting 7 pi over 4.
8 pi over
8 pi over 4, which leaves me with theta prime is what? Pi over 4. Okay, and remember your reference angles have to be acute. Acute means what?
Less than 90.
Less than 90 degrees, okay, or less than pi over 2. Okay, so just if your answer, because what would have happened if we had left this as 15 pi over 4, we would have gotten the answer to have been negative 7 pi over 4, which is not acute. Okay. Let's see.
Can we do it? Do you have another like negative radian one? I'm not trying to kill everybody, but I just want to like.
Yeah, we can do another one.
I'm sorry.
Let's do negative. Hold on, give me a second to come up with one, because there's not one, but like,
Oh,
let's
It
see.
was like negative 32.
you're done. You're out.
Give us the hardest one.
Let's do
Give us a word.
negative 4
Give us a word
pi
problem.
over 3.
Oh my gosh, no.
Just because we also haven't done one in that quadrant, so that would be something beneficial to do. All right, so
Not like to know.
my theta, okay, I'd be coming around 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That looks rough, so let's just sketch that again real quick. Okay, so that would be up here. This is theta. So then my theta prime touching the x-axis.
Ooh. Yeah, see? I almost did the Y.
You almost did it, no.
That's what I'm saying. Sounds annoying that I keep saying it, but it's going to help you when you get to the
Yeah.
test. It's like physics. The other day I showed them a video. They will never forget what the first and second law of thermodynamics is, because that was one of the goofiest videos in the world. Yes.
Doesn't theta have to be positive?
Yep, so we're going to redraw theta to be right here. We're going to use this one instead.
Oh,
Yep. I was going to say that, and then Josh was like, I almost did a no-no thing.
I wasn't
I'm
sure.
sorry.
It's okay. Josh was just letting us know that he was being an example and why I'm not actually being annoying. Just kidding. Okay. I don't know why I'm looking on there, because it's not like I've already done it. So y'all are going to have to tell me what the formula is, because I don't have it.
Okay.
Pi minus theta.
Yeah.
Okay, so
Wait, what?
theta prime is pi minus theta. I'm going to take y'all's word for it, because I don't have that one in front of me, so.
Probably right.
All right, so our theta that we're using, what is this theta value?
2 pi over 3.
2 pi over 3 is the theta value that we're using.
I literally just guessed.
Because 1 pi over 3 would be right here, so 2 pi over 3. So, in terms of pi over 3, how would I rewrite pi to be 3 pi over 3?
Why is they're like all just pi over whatever now? So it's pi over 3.
So the answer would be pi over 3. So theta prime is pi over 3.
Okay. That was,
The first one was pi over 6. The second one we did was pi over 4. And now this one's pi over 3. We're just going in order.
Did we talk? No, we have not yet talked about evaluating the functions without a calculator for.
no.
Okay, we have not done those yet. All right, so evaluate the function without using a calculator. So 24 is the secant of 135 degrees. So, I'm gonna take this away and put this unit circle back up here real quick. Secant goes with what trig function? Actually, I'm gonna write that down first. Cosine. So, another way I can write secant, okay, is 1 over the cosine of theta, which in this case is 135 degrees. Okay. So I'm going to go to my unit circle, and I'm going to look for the cosine of 135 degrees, okay? So I'm going all the way around. 135 is here. Which value is cosine? X or Y?
It's the X, right?
Cx value. Okay, so cosine is x, so it's going to be this negative root 2 over 2. Okay, so this is 1 over negative root 2 over 2. If I divide by a fraction, it's the same as doing what?
Keep change flip.
Yep, multiply by the reciprocal, keep change flip. Must have heard that from my mom.
Yeah.
Heard that in like
But she said it a lot.
6th grade.
I think the one she used to say is keep it, change it, turn it. Because that was
Yeah.
what somebody she taught with always said.
Oh.
And then somebody else said keep, change, flip. So then she started changing to that one.
Pretty sure that was Miss Paul.
I think she realized that's what Miss Holly was saying. So she
Yeah.
started switching to say the, yeah. All right. So then obviously 1 times all of that is just the stuff that's left over. But what's the problem?
Can't have
There's
a
something
square
on
root.
the bottom.
You can't have a radical on the bottom.
Can't have a radical on the bottom, so I need to multiply by the square root of 2 over square root of 2. And so then I'm left with
Oh, but
minus
that's
2 root 2 over 2, which is
Yay.
Square root of 2.
minus the square root of 2. So the secant of 135 degrees is equal to minus the square root of 2.
Wasn't even a word.
I really thought this whole time that the cosine was the one
Well, I'm glad we had this discussion then, because that could have been really bad.
So sine is the y, and then tangent is the.
But that's just,
Tangent's y over x.
That's just confusing. Why would they do that?
All right, 26. The sine of negative 150 degrees. Okay, so obviously sine is something that we know, but I'm going to have to find minus 150 degrees. So I've got to work my way backwards, right? So I know from here to here is 90.
It'd be at the 225.
Are you sure?
Wouldn't it be at the 150?
It'd be at the
Okay, so minus 90. Okay, minus 120. Okay, notice these match up here.
Oh.
So minus 120,
No,
minus 135, minus 150. Okay, it's partners right there. So minus 150 is here at 210 degrees. So this is equivalent to the sine of 210 degrees. Okay, if you want to think about it that way instead. So what is the sine of 210 degrees? Or
negative 1/2.
negative 1/2 y value. Negative 1/2.
Oh, it's the trunk.
It's okay. Jeez.
All right, just because I want to make sure that y'all actually see an example of some of these. 27. Cosecant of negative 420 degrees. Okay, what does cosecant go with? Sine. So this is equivalent to 1 over the sine of negative 420 degrees. Okay, so let's count that, and then we'll write what it's equivalent to in the positive direction. Okay, so I know that all the way around is 360 degrees. Okay, so if I go another 30, that's 390. And then another 30, okay, is 420. So it's the same as the sine of 300. So 1 over the sine of 300. And the sine of 300 is what?
That one number.
Which one?
Negative root 3 over 2.
Negative root 3 over 2. Okay, but that's the sine. Don't do what I just did. It's 1 over that value. 1 over the square root of 3 over 2. We say it was negative, didn't we? It's negative. Okay. Multiply by the reciprocal. So that's going to be 2 or negative 2 over the square root of 3.
And then you're like, oop, can't do that.
So multiply by the square root of 3 over the square root of 3, which gives you, so that's what cosecant is equal to. Okay, so we found the sine of 300, but that was on the bottom. Okay, so we had to actually write it this way. So 1 over that value, and then we had to just simplify it so we didn't have the radical on the bottom anymore. Alright, I'm going to do one more. It's going to be another odd one, but I want to make sure that you guys know how to do these. Cotangent of negative 8 pi over 3. Now, I'm going to show you two different ways that we can think about this one. Okay, cotangent is equivalent to what?
Tangent.
Okay, 1 over tangent. So I could think about this as 1 over the tangent of negative 8 pi over 3. Another just random thing that I'm pretty sure you would have at least had in your notes is that tangent is equal to sine over cosine, okay, which is y over x. Okay, cotangent is the reverse of that. It's cosine over sine. So I could think about this one also as the cosine of negative 8 pi over 3 over the sine of negative 8 pi over 3. Okay. Both ways will give you the same answer. With some things, you may prefer this one over this one. It just depends. Sometimes this allows things to cancel easier, so it's like less math that you have to do, but I don't care which way we do it. I'm just showing you two different ways that you could get the answer. Okay. So tangent of negative 8 pi over 3. Need to go and count this. So I know that I want in groups of pi over 3's. Okay, so it's negative. I know that all the way around one time is how many pi over 3's? 6 pi over 3, so I need to go a little bit farther. 7 pi over 3, 8 pi over 3, so that's the equivalent of 4 pi over 3. Okay, so this is equivalent to 1 over the tangent of 4 pi over 3. The tangent of 4 pi over 3 is equal to what?
Square root 3.
Okay, square root of 3. So this is equal to 1 over the square root of 3.
We can't have none of that.
Can't have that. So multiply by the square root of 3 over the square root of 3. And that leaves us with what?
Square root 3 over 3.
Root 3 over 3.
So now it's a thing.
So not too bad.
I like it.
Alright, so in terms of problems, okay, again, it is not homework tonight, okay? You have class time tomorrow to do it. So the problems that you need to do are three, 5, 7, 15, and then let's see, 17, 19, 23, and then 25. We already did 27, we did 29, and then 31. Okay, so a little bit more than usual, but you'll have the entire class tomorrow to work on it, and you'll have me as a resource if you have questions or get stuck or something like that that you can ask as well.